All right, let's continue our discussion of 1.3. So this is chapter 1, section 3, part 2. So we're talking about the same material, properties of numbers, and we're going to extend our knowledge a little bit more by doing a few more example problems so we can just practice these concepts and make sure that we've really got it down as we go forward. So we've already talked about being able to reason through these examples. We've done order of operations, and we've recognized different properties of equality, different identities. We wrote all those down yesterday. Specifically, commutative and associative properties are some that we want to stress, as well as substitution. They come up a ton. So if we move straight into another example, this is going to be just a short review of the concepts we touched on yesterday. The first example asks you to write down this expression. We want to evaluate this whole thing. We have 1/3 times the quantity 10 minus 7. All that is being multiplied. Then we're going to add 4 times the quantity in parentheses 18 divided by 9 minus 1. So this whole thing we need to evaluate. Now if we remember practicing PEMDAS, we know that the order of operations have to be taken into account. Certain things need to be done before other things. So we know the P for parentheses must come first. So let's do all of those things. We know 10 minus 7 is going to give us 3. So I'll substitute that in here. And then we still have the 1/3 being multiplied. 1/3 right there. Now, so we have 1/3 times the quantity, which now is 3. We're going to add, and we'll see what we get here. We're still working on the parentheses, so we just leave the 4 there. And let's solve what's inside of this parenthesis here. So 18 divided by 9 minus 1. Well, I know that when it comes to order of operations, division comes before subtraction. So if you think about PEMDAS, division, the D in PEMDAS comes before the S in subtraction. So 18 divided by 9 we have to do first. We know if we do this in a calculator or in our head, 18 divided by 9 is 2. So that's going to be 2. And then we can bring down our minus 1. So one step will get us here. Now we know that 1/3 times 3, we talked about yesterday that if you have something and you flip it and multiply those two things by each other, those are multiplicative identities and their product will always come out to 1. If that's too complicated to remember, you know 3 divided by 3 is 1. So when these two things multiply with each other, that's just 1. Plus, we know that the inside here, we've got 2 minus 1. 2 minus 1 is just going to be 1. And 1 times 4 is 4. So we have 1 plus 4. So we know our final solution here is going to be 5 when we take all things into account. So our final answer should be 5, letter choice B. So let's see that there. After all that work, we get the final answer of B. Notice again, because it says evaluate, we're going to get a raw number. We're going to get a concrete number as our answer. There will be no variables there, so keep that in mind. So you should have written the question and worked through those steps to get the solution of 5 for your notes. This is example 1. Now, moving on to another real-world example. So we had another example yesterday about horseback riding. This one, somewhat similar, we're talking about transportation. So Darlene's riding through the city train from multiple stations. So she starts at the Winchester Street station and arrives at the airport. We want to know how far does she travel on the train. So given that there are 5 stations here, they tell us the distance from the previous station here, we can use all these values, add them together, and find out what is the total distance that she traveled on the train? So we need to take this 0, 0.6, 1.2, 1.8, and 1.9 and sum them. So if we do that in a calculator or in our heads, we can figure that out. And you should be looking at the answer choices possible. And after simple calculation, of course, you should have written down these two sentences by now. How far did she travel in miles? Well, I know 0.6 plus 1.2 is 1.8. 1.8 plus another 1.8 is 3.6. And 3.6 plus 1.9 would give me 5.5. So there we have our solution. She went 5.5 miles total from Winchester Street to the airport. This is example 2 for today. The point of this is giving us a real, tangible context for how we can use addition properties and commutative properties to solve problems with real context in the world. So there you see a problem having to do with transportation. We all travel multiple miles per day on our cars, on our bikes, walking, exercising, whatever the case may be. And so these are real facts and figures that you can really see in action on a daily basis. Moving on, example 3. We want to evaluate this whole expression here. So we have 4 numbers, and they're all being multiplied with each other. So because of the commutative property of multiplication, we can multiply these in any order and we'll get the same answer. So if this is fine for you, then you can leave it the way it is. If you'd like to change the order, you're more than welcome to. So if you feel more comfortable saying you want to multiply 3 times 3 first, then 5, and then 4, totally up to you. So the order does not matter. But if we just keep it as is, just for simplicity's sake, we know 3 times 5 is 15. So if we mark that here, we know 3 times 5 is 15. I know 3 times 4 is 12. So if I bring that down, that's 12. And then we need to know, what is 15 times 12? Well, if I think 15 times 10, I know is 150. And then 2 more 15s is 30. So 150 plus 30, my total should be 180. So of the available answer choices, we know that our solution should be letter choice D. So example 3A in today's notes is D. When we evaluate that whole expression, our solution is 180. And again, we can write these in any order we want because of the commutative property. It's fine if you leave it as is. Just make sure you write the question and a couple steps, and our solution 180. Now, one more example to look at. We want to evaluate this expression given, and this is similar to a problem we had yesterday. So we have a fraction 1/4 being multiplied by 48. So if we think about what this is saying, we can actually rewrite this. So if we want to rewrite this as fractions in a way that we can see what's on top and what's on bottom, we can do that. So I'll write my 1/4, and I know that we're multiplying. 48 is a number. It's a whole number, but we can write it as 48 over 1 since it's a whole number. And then if we want to multiply a fraction times a whole number, we can just multiply these things across. So multiply these numbers across like this. We draw a little arrow. So 1 times 48 would give us 48 on top. And our numerator, 4 times 1, would just be 4. So you can see how 1/4 times 48 is really the same thing as 48 divided by 4. which if you divide that out, 48 divided by 4 is really 12. We would subtract, and we can do the same thing over here. So 99 I'll write as a fraction, 99 over 1. And we're going to multiply by that fraction given, 1/9. Now we have 99 over 1 times 1/9. So again, we multiply straight across. Multiply straight across with those fractions. So this would give me 99 on top. And we would get 1 over 9 on the bottom. Or excuse me, 9 on the bottom. 1 times 9 gives us 9. And I know 99 divided by 9 is really just 11. So our final step here, we have 12 minus 11, which we all know is 1. So when we evaluate this whole expression that looks super complicated, it really just comes back to be 1. That is our final answer there. So you see a couple steps. We have our original equation here, and our solution is 1. And so here's that last step that we showed. You end up with 12, 11. We're subtracting, finding the difference. And our answer is 1 for example B. So given any information, you can evaluate these by just breaking it down, taking simple steps, being patient, and finding your solution. So this is the end of part 2. We're going to do more work with what we started yesterday and a couple higher level thinking problems. So hopefully we're all on task working on those and asking any questions we might have. Next time we're moving forward with section 4 in chapter 1. That'll be 1.4.